All right, this is continuing the worksheet. We're looking at problem 6. This is one of those you have to do use substitution. Why? Look at the degree on the inside. The degree on the inside is 1, and the degree on the outside is 1. So there's none of this stuff we did for number 5, right? There isn't this lurking derivative of the inside outside, the x cubed. So when you have that, I'm going to do a change of variables. I'm going to let u equal x plus 1 and du equals, the derivative of x plus 1 is 1. So I'm going to write the 1 for emphasis. Generally speaking, we don't write the 1. Right? So I have dx going to be replaced with du. So I have this extra x left over. So the x plus 1 I can replace with u, but this x is kind of extra. So what I'm going to do is take this equation and solve this equation for x. So that's going to be u minus 1 equals x. So now I have something to replace the x with. I'm going to replace it with u minus 1. All right, so let's write the integral. So x is being replaced with u minus 1. And the square root of x, the x plus 1 is being replaced with u. Right, because x plus 1 is u. And the dx is replaced with du. So that's du. Okay. Now, because I changed variables and I have numbers, I can change the numbers too. Right now, this is x equals 0 to x equals 1. So basically, I'm going to plug in 0 for x. 0 plus 1 is 1. So u equals 1. I'm going to replace the x with 1. 1 plus 1 is 2. So that means u is 2. All right, let's continue that. Now, I'm going to do an algebraic rewrite just to make things easier to understand. So that's u minus 1. Square root of u is u to the 1/2. And then what I'm going to do is distribute that u to the 1/2. So u times u to the 1/2 is u to the 3/2. And 1 times u to the half is u to the half. So if you're wondering where that 3/2 come from, remember u is u to the 1. So it's 1 plus a half. 1 plus a half is 3/2. All right, continuing. Now I'm ready to use power rule on the pieces here. So I'm going to add 1 to the exponent and divide by the exponent. So 3/2 plus 1 is 5/2. Divide by 5/2. 1/2 plus 1 is 3/2. Divide by 3/2. And I'm taking that between 2 and 1. Okay, let's clean it up a little bit. That divided by 5/2 is same as multiplying by its reciprocal. So it's 2/5 u to the 5/2 minus 2/3 u to the 3/2. Take that between 2 and 1. Plug in the 2. So it's 2/5 times 2 to the 5/2. And I'm still plugging in the 2. 2 to the 3/2. Oops. 2 to the 3/2. Minus, so I'm going to put that in parentheses, keep it separate. So I don't really need these parentheses. I like them just to keep it in my mind that I plugged in 2 to this part. Now I'm plugging in 1 into that part. And 1 is a special thing. So 1 to the 5/2 is just 5/2. I'm sorry. 1 to the 5/2 is just 1. So I just do 2/5 minus 2/3. Okay. This is going to be very unfriendly. All right. Okay. What is 2 to the 5/2? 2 to the 5/2. Well, remember the exponent in the numerator, or the numerator of the exponent, is just a regular exponent. So that's 2 to the 5th. So I can read that as 32, and the 1/2 is square root minus 2/3. So 2 to the 3rd is 8, so it's square root of 8. All right, and what's 2/5 minus 2/3? 2/5 minus 15. So that's 6/15 minus 10/15. So that's negative 4/15. Just double check. 3 times 2 is 6, 5 times 2 is 10. Okay, so it's going to be negative 4/15, so it's plus 4/15. All right, that's 2/5. And then square root of 32 is 4 root 2. And square root of 8 is 2 root 2. And this is just getting worse and worse. And then now I can combine these two. Well, let's clean up a little bit first. So that's 8 root 2 over 5 minus 4 root 2 over 3 plus 4/15. Okay, so you might be wondering how to get the 8. It's 2 times 4. I can do that. And 2 times 2 is 4. All right. Now we find the common denominator. So the common denominator is 15. So all these gets combined together. I'm going to write it up here. Goodness gracious. So multiply by 3. That's going to be 24 root 2 over 15 minus multiply by 5. That's going to be 20 root 2 over 15. And I still have the 4/15. Now I can subtract 24 minus 20. They both have square root of 2, so I can combine them. So that's going to be 4 root 2. And I'm going to write it over one fraction, or one denominator of 15. Final answer. Goodness gracious. Sorry about that. All right. Next. Probably just do one more for this video. Number 7. Okay. So this one, you can see I have x cubed here, and x cubed is an inside function. What is the derivative of x cubed? Well, it's 3x squared. So this is only missing a 3. So I don't have to do a change of variables. I compensate for that 3 I put in there with a 1/3 on the outside. Now I can just integrate. I'm just going to integrate cosine because I have the derivative of the inside lurking out here somewhere. So the cosine is the derivative of sine. So when I integrate, it's sine x cubed, take it from 0 to the square root of pi. All right? And that's horrible. All right. And this one, we're just going to plug it in and just let it go. All right? So 1/3 sine of square root of pi cubed, right, minus 1/3 sine of 0, right? 0 to the third is 0, so it's just 0. And sine of 0 is 0, so final answer is just going to be 1/3 sine of square root of pi to the third. And that's perfectly fine. All right, can we do that one? Yeah, we can do that one. All right, we'll make these videos about 8 minutes long. 10 minutes long. All right, so here, if you look at this, what is the derivative of x squared minus 2x? Well, the derivative of that is 2x minus 2. So I'm writing this for scratch work. So this x minus 1 is missing a factor of 2. So that means I can multiply by 2, compensate for that 2 with a half. So I don't have to do that nasty change of variables thing. So that's going to be 1/2. Now I can just use power rule on this part because the derivative of x squared minus 2x is lurking out here. I can just do the power rule on the 3. So that's going to be x squared minus 2x to the 4th, right? Add 1 to the exponent, divide by the new exponent from 0 to 2. Or 2 to 0, whatever. Clean it up a little bit, so it's 1/8 x squared minus 2x to the 4th. Take it from 2 to 0. 1/8. Plug in the 2. So 4 minus 4 to the 4th minus, plug in the 0, get 0, and I get 0. Wow, that was really anticlimactic. But let's stop there.